All right, good morning, class, and welcome to this lesson on Momentum 4, More Collision and Explosions. This is going to be a continuation of the Momentum 3. This is going to be a continuation of Momentum 3, in the sense that we're just looking at the same things. We are going to be looking at the conservation of momentum being the momentum initially equals momentum finally. Initial momentum equals final momentum. And we're going to be looking at just a couple more situations to identify and set up an equation in order to solve for it. And so I'm going to look at a situation now in which two objects stick together. Two objects stick together. Okay? Always good to draw a picture. Before and after, especially in these kind of situations. Before, after. And I'm going to do a classic, just a football tackle. Okay? And so we're going to have one person running. This way. We're going to have this is our offense. This is going to be our defense. Going to go tackle him. Okay? So in this kind of situation, before they're going to hit, they're going to get tackled, and we're going to say that afterwards. Actually, I'm going to hold off to after right now. Okay? So let's go over here. I'm going to rewrite this over here. Momentum initial equals momentum final. M1 V1 initial, and I'm going to write down minus M2 V2 final. Why am I writing minus? Because in this system, once again, I'm going to call to the right positive. That means this number is positive, but since this person is running to the left, they have a negative velocity, and because this is negative, that makes that negative right there, okay? And this is going to equal, it's a tackle, okay? This is going to make this where they stick together. After the hit, they're going to wrap up, and they're going to be one unit. And because they are now one unit, they're going to be moving with the same speed. So I'm going to write this out: M1 V1 final plus M2 V2 final. But the reality is, because they are stuck together, or they are wrapped up together, V1 final equals V2 final. If one guy is going to be moving at a certain speed, the other guy is going to be moving at a certain speed. So we can rewrite this whole equation as M1 V1 initial minus M2 V2 final equals M1 plus M2 V final. Because if these two are equal, all I did was factor that out to right here. So if two objects stick together, we can combine their masses because of this final velocity being the same for both of them. And let's just say that when they get hit, they go back this way. They go back to the left. Okay, so they both fall. Guy has a ball. Guy tackles. I can't draw it. You get it. They're falling that way. Okay, they're falling to the left. That's going to make, and let's say the question started off with find V final and direction. Well, after we solve this whole thing, you know, we're gonna divide by M1 plus M2 on both sides. Okay, we're going to get a final velocity. Okay, we're going to get a final velocity over here, and it is because of this final velocity here. This final velocity is going to be negative. Okay, the final velocity is going to be negative. That tells us from this question that the direction means they are going that way. The direction means they are going that way because of the negative sign here. Because negative means left, and just for example, this is why we want our football players nice and big, because their running is a product of their momentum. If they have a larger mass and they can run fast, so big fast guys are the best, because if they have a bigger momentum, when they hit somebody else, they are going to cause them to go in the opposite direction they want to go. Okay? I mean, if the person falls backwards, the ball's marked where their feet were. If a person falls forward, they get an extra 2 yards to get the ball marked right there. So that's kind of random, I know, but this is why we want big fast football players, is because of the product of their momentum. So let's do one more situation here, and this is going to be called an explosion. This is going to be called an explosion, and honestly, this is way cooler than it sounds. Okay, this is not a bomb. Okay, although we could do a situation with a bomb. An explosion means one object becoming two objects. Okay? And we're going to take a very classic example that they use in almost every single book, where we have two people on skates, typically a guy and a girl, and what they do is they push off each other. So, okay, here's the guy, here's the girl, and they push off and they go in different directions. So this would be before, and this would be after, where the guy they're both skating backwards, and the girl is skating backwards as well. Okay, so they were both not moving. And then now this guy is going to the left, this girl is going to the right. Okay? Well, write the equation out again. Initial momentum equals final momentum. And so we're going to have m1v1i plus m2v2i equals m1v1 final plus m2v2 final. Well, these situations are very easy math-wise, because when they are not moving initially, you get to cross out the whole left side of the equation and make that 0. And once again, if we'll call to the right positive and the left negative. Okay, come on, pen. We call to the right positive and the left negative. This guy has a negative velocity, so we'll say I'm going to write over here. We'll say 0 equals negative m1 v1 final plus m2 v2 final. And if we want to solve for any of this, we're going to add this to both sides. And we're going to get m1 v1 final equals m2 v2 final. And if you recognize this as an explosion equation, or an explosion situation where one object, because these two are considered one object to start off with, this is the system, they split up into two. If you recognize this as an explosion situation, you can automatically go straight to this point right here. I wrote it out for you here to show you where we got it from, but the reality is it's this simple. It is m1 v1 final equals m2 v2 final, or just m1 v1 equals m2 v2, because there really is no point in writing final, because that's the only velocity we're going to see. So this is just another example of conservation of momentum, where two objects are turning into two, as opposed to two objects colliding like we did before. It is now one object becoming two. Okay.